Alright, so hi, hello, welcome again to this another video. So in this video, we'll talk about the module 5, which is the searching and sorting algorithms. So in this module, this one focuses on the various searching and sorting algorithm that is commonly used in programming, specifically the linear search, binary search, jump search, for the searching algorithms. And then we also have the sorting algorithms, which is the insertion sort, bubble sort, merge sort, and then lastly is the selection sort. Okay, so without a further ado, let us start now. So let's start with searching algorithms first. So searching is the process of locating given value position in a set of elements. So here are some applications where we can apply, the searching algorithms. So the first one is, let's say, looking for an entry in a database. Say used in virtual space applications, or specifically the hunting for the best chess moves, or looking for the shortest path maze. Okay, and then locate web pages through search engines, and then searching files in a memory. So we can apply the algorithms in searching with those applications. So here are some commonly used search algorithms. So we'll start with linear, or sometimes they call that one, or we call that one sequential search. So this one involves checking each element of the list in turn until the desired element is found. So this one relies on the technique of traversing a list from start to end by exploring properties for all the elements that are found on the way. So I would say that this is the simplest way of searching. So starting from the, say the leftmost side and then going to the rightmost side until you found the element that you are looking for. Okay, so I think there is no need for me to explain this one a bit more. As you guys can see in the picture, it's very simple and very straightforward. So starting from here up to the last one, so it will search those cells one by one, okay, or the elements one by one. So second is the binary, or the half interval or logarithmic search. So this one is specifically designed for searching in sorted data structures. So this one is more efficient than linear search, as they repeatedly target the center of the search structure and divide the search space in half. So this one, it will get the total counts of elements and then divide that one into two. And then after dividing that one into two, then you will now get the, let's say, the middle part. And on this example, we have this one as our middle part. And then as we go on the right side, you again count the total elements, and then we get the middle part. So let's see, from here 1 2 3 4 5, so the middle of that one, say 2.5, or this one, this 65 right here, and then going back to the left until it reaches the last one. So you just keep on going like that. Okay, so the next one is jump search. So this one check fewer elements than linear search. So by jumping ahead by fixed steps or skipping some elements in place of searching all elements. So as you guys can see, this one skip two cells, okay, or two characters. So starting from 0, it skip those two and then proceed to the third one. And then skip another two and then proceed to the next one. And so on and so forth. So the next one here is 9, skip another 2. Next one is 12, skip another 2, and then the next one is 15. So this is how jump search works. So of course, depending on how many lines or how many characters you're going to skip. Okay, is it by 5, by 3, by 10? Okay, that depends on your program. Next one is sorting algorithms. So in sorting, this is a process of arranging a list of elements in a particular order. Say ascending or descending, so vice versa. So this one is commonly used in search algorithms. So the first one is insertion sort. So one element from the input element is consumed in each iteration to find its correct position. So you guys gotta take a look on this one for now. So as a raw file, we have this 1 4 3 2 10 12 1 5 6, and then let's see, we wanted to arrange this one from, in an ascending format, so from lowest to highest. So it will start in comparing, the first two characters of 4 and 3. So if it's lower, then it will go to the left side. But if it's higher, then it will stay on that specific position. So it will keep, comparing that one up to until the last one. So we're done with the 4 and 3. The next one is the 3 and 2, or rather the 4 and 2, since the 4 now became the second position after arranging this one into this kind of format. So 4 and 2, of course, 2 will go here since this one is lower. Okay. And at the same time, as you guys can see, it already go to the most left side since it already compared that 1 to the number 3. So it just keep on comparing that one from that position up to the left side, one by one. So the next one is 10. So since 10 is higher than those three previous characters, then it will stay in that position. So it's the same with 12. It will stay in that position. But 1 is lower than 12, lower than 10, lower than 4, lower than 3, and 2. So that is why it will go right here. So we now have this format. So 1, 2, 3, 4, 10, 12, and then comparing the 5. So 5 will go right here, okay, because 5 is not lower than 4. And then proceeding to the next one, so we have here now the 10, 12, and then 6. So 6 is basically lower than 12, and then so it will go right here. Okay, and once you're done with that one, then that's the only time that it will stop sorting this one. So it just basically sorted the cells from lowest to highest. So 1, 2, 3, 4, 5, 6, 10, and then 12. Okay, so I hope we are clear with the insertion sort. Next one is bubble sort. So this one repeatedly comparing pairs of adjacent element and then swapping their positions if they exist in the wrong order. So a bubble order is composed of two. So say this is your raw character or raw file. Say 5, 3, 8, 4, and then 6. So bubble sort will start from the same with the leftmost side. So 5 and 3 will be compared. So if it's lower, then it will be swapped. So that's what happened in here. So 3 is lower, so it will go to the left most side or the left side, and then 5 will go right here. And then 5 and 8 will be compared with each other. So 5 and 8 is already okay, so it will stay as it is. And then 8 and 4 will be compared. So 4 is lower, so it will go right here. And then 8 and 6 will be compared, and that 6 is lower, so 6 will go right here. So as you guys can see, this one didn't really arrange this one from lowest to highest, but that is how a bubble sort works. So we have 3, 5, 4, 6, and then 8. So we have an imperfection right here when it comes to arranging. So if you want that one from lowest to highest, then you have to apply the insertion sort. But if you want to do it, in one comparison, so in a bubble format, or let's say in 2-cell, okay, comparison, so that is a bubble sort. We'll keep on comparing pairs in adjacent element. So as a result, we have here 3, 5, 4, 6, 8. Okay. So for the merge sort, so this is the last one, I think. No, second to the last. Okay, so this one a divide and conquer algorithm based on the idea of breaking down a list into several sublists until each sublist consists of a single element. So this is actually the goal of this merge sort. Single element, and merging those sublists in a manner that results into a sorted list. So this one is similar with the insertion list, where we can arrange everything from lowest to highest or highest to lowest, though it's just in a form of say separating things. Okay, so we have here the raw file, so that 12, 35, 8, 7, 8, 6, 9, 28, and then 7. So as you guys can see, we have 1, 2, 3, 4, 5, 6, 7. So one part will be 4, and then one part will be just 3. So if it's 8 cells, then 4 and then 4. But since we cannot have a 3.5 and then 3.5, so one will go 4 and then one will go 3. So as a result, we have the 12, 35, 87, 26, and then the 9, 28, and then 7. So in here, it will just keep on dividing those cells. So from 7 became 4 and 3, from 4 became 2 pairs, from 3 became 2 and 1, and then from 2, of course, will become just 1 and 1. Same with this one, 1 and 1. So from 2 became 1 and 1, from 7 became just 1. So there is nothing tricky in here. So you're simply creating a division. Okay, putting an arrow here, and then this is the 35, this is 12, this is 87, 26. Okay, and then in here, as you guys can see, we are now going to compare. So after getting the single array or single element, so there will be a comparison that will be happening here. So 12 and 35 will be compared with each other, 26 and 87 will be compared to each other, and then actually right here, it's like what's happening is we are already comparing this pair to this pair, and then it's already arranging, okay, the elements from lowest to highest. As you guys can see, 12 and 35 supposedly will go right here, but we have here 26, okay, because it already compared that one on this part. So 12, 26, 35, and then 87. So this one now is in the form of ascending format from lowest to highest. So the same with this one. So 9 and 28 and then 7 is now being compared. So this one actually goes like this one. So 7 will go right here, 9 will go right here, and then last table, the 28 will go right here. Then after that, we'll have another comparison again. Okay, so 7 will go right here, 9 will go right here, followed by 12, 26, 28, 35, and then 87. So we could say that that one is similar with the insertion list, but which is another way of doing that. Okay, so forming a single character, and then comparison, another comparison, and then having this one as a sorted ascending format. Alright, so for the last one, we have the selection sort. So this one is finding the minimum or maximum element in an unsorted array and then putting it in its correct position in a sorted array. So we have two parts for this one. It's just basically it's sorted and then unsorted, and then we have one part that we are always looking for. On this left side, we are always looking for the minimum element, or let's just say the lowest element or smallest element. So in here, as you guys can see, 2 is the minimum, okay, or the lowest element. So this minimum will go to the left side, leftmost side, and that is called the sorted array, and then the rest will go to the right side, so separately. So this one is called the unsorted array. And then in here, we have another the most minimum element, which is the 4. So it will go again the leftmost side together with the 2, and then the other 2 will go to the right side, which is the unsorted array. So just keep on doing that one, and here is again the lowest element, so it will go to the left side, and then the remaining will go to the right side, which is the unsorted array. And then the last one, of course, it doesn't have any other elements to be compared with, so it will now go to the leftmost side until there is no unsorted array anymore. So that is the goal of this selection sort. So that's basically it for this module. So this is just a pure concept, of this selection, merge sort, bubble sort, insertion sort. So those are for the sorting. So we also have the jump search, binary search, and then linear search. Okay, so I hope you guys have at least understand now the basics of those searching algorithms and then sorting algorithms. So that's pretty much it for this video. So thank you for listening. So goodbye and see you guys next time. So peace out.